Hello, everybody. It's a crazy math nerd here, Kitty Morgan. Trying to talk to you a little bit about this new curriculum that we've developed and also talk to you about the first day and why it was designed the way it was. So notice that I have pulled up your scope and sequence for AP Calculus, and every scope and sequence has a little unit note. So that is me trying to write to you and talk to you a little bit about why this was developed. And this actually was developed for students who could even be coming straight out of Algebra 2 to be successful on the first day. So notice that the first thing you do on day one is called Calculus Day 1, and finding the limit as x goes right and left forever. So what we're going to do is we're going to take a approach to this that makes this just asking questions and talking about the y values, and then the next day we're going to come back and put some symbols with it. So notice that for every day you have the title. There's your title. You have your curriculum framework that is associated with it. You also have your prereqs listed. This is the teacher noticed me talking to you a little bit about what to kind of be ready for. And then as we move along, here's the presentation strategy. And this is the suggestion that I have that will hopefully give you enough time to get everything that you need done for today and be successful with the task. So notice that I actually suggest certain problems to work and then give some pedagogical things about stop and go signs and just let the kids work together kind of things. And that's all of day one. So let's look at day one and let's talk a little bit about how that was developed. So this is the material for day one, and it's called Calculus Day 1 because I didn't want to call it limits because we're not saying that word yet. So I asked in the presentation part of your scope and sequence for you to do number 3, 5, 9, and 11. So we're going to talk about how we would go through that. So for every graph, you're going to ask your students to answer two questions. How do the y values change as the graph goes left forever? And how do the y values change as the graph goes right forever? So how do they change? And the reason I ask you to do 3, 5, 9, and 11 is because these will change in a way that will be similar to how some other things will change. And so you're trying to kind of show them how to talk like this. So if I were to look at how do y values change as the graph goes to the left forever, then I'm probably going to grab my highlighter and I'm going to go on the graph in the middle and I'm going to go left forever. And notice that as I go left forever, my y's go down forever. So I'm actually going to write that. That's as hard as it is. Down forever. And then for part B, it says, how do the y values change as the graph goes right forever? So if I get on this function and go right forever, then the y values go up forever. And I know this is very simplistic. I know this is very easy sounding, but this is the first day of calculus. And one of the things we want to do is build that confidence. So I didn't want it to be real hard, and I wanted it to be an access point for all students to start doing calculus feeling problems and be successful the first day. So let's go look at number 5. All right. As you go left forever, well, there is not a left forever, so we have what we call a domain issue. Because this is the square root of x, there are no values to the left of 0 because that would make the y values imaginary. And so when we do this, we allow ourselves not only to talk about the calculus, but a lot of the pre-calculus that is woven into here that we want to make sure that they know. And then in part B, as I go right forever, I'm not going very quickly, but I am going up forever. That's what the Y's are doing. So notice the question we are asking is about the X's, like that tells us the direction to look, and the answer we're writing down is what the Y's are doing. All right, let's go look at number 9. So as I go left forever, ooh, look, it looks like my graph is stopping at 0 or chilling out at 0. So I'm actually going to write the Y's are, looks like they're, why don't we use this new word, approach. It looks like that the Y's are approaching Y equals 0, or approaching 0. And then on this side, going right forever, notice that this side is kind of doing the same thing. So the Y values are approaching 0. Well, yeah. Why should I say that over again? They're approaching 0. So we're starting to use these words that we want them to use when talking about limits, but I haven't put any funny symbols or scary things. I'm just saying answer the question. And remember, I'm doing an example that should of each type of weird problem so that we have something for them to go with. So in number 11, as I go left forever, I have a domain issue. In number 11, as you go left forever, again, it doesn't really go in a certain direction or get stopped by something because we have a domain issue. And let's talk a little bit about who he is. This is that half circle, and so you cannot go outside of that circle for any Y value. So you really asking me where it goes as X goes left forever is not a good question because of the domain issue, and the same thing for the other side. So we're just trying to get them used to seeing these 19 basic functions and answer questions about what the Y values are doing as you go left and right forever. So number 15 is the last one that I think I put on the presentation strategy for the day 1. And this is a little trickier one. So when I talk about this one, as you go left forever, notice that we just would keep doing the same thing because we know what sine and cosine kind of do. They do that repeating pattern. So I'm going to say that the Y's repeat a pattern. And going to the right, the Y's also repeat a pattern. So it doesn't go up forever or down forever or go to a particular value, approach a particular value. It keeps doing the same thing. So it's repeating a pattern. So after we've done those few, they should be able to sit in partners and complete the rest of it pretty easily. And they might have a few questions, but that's why you walk around and use a stop and go sign so they can turn it red if they need your help. And you just ask probing questions. And what's so nice about this is no matter where a kid has been, they get exposed to the 19 basic functions while getting ready for limits. So we're doing a double duty here. Well, after they've worked, then we'll go to day 2, and I'll do a video about the notes for day 2.